Have you ever wondered what rogue planets are and how they differ from regular planets? Welcome to this fascinating journey through the cosmos. Our universe is an enchanting place, teeming with an array of celestial bodies. Among them, planets hold a special place in our hearts. We live on one, after all. Planets, as we commonly understand them, are celestial bodies that orbit stars. They come in all shapes and sizes, from the gas giants like Jupiter to rocky planets like our very own Earth, each unique and intriguing in its own way. Yet, as diverse as these planets are, they all share a common trait. They are tethered to a star, orbiting it in a delicate cosmic dance. But there's another class of planets out there, drifting alone in the vast cosmic darkness, called rogue planets. So, what exactly are these rogue planets, you might ask? Well, let's dive right into the fascinating world of these cosmic drifters. Rogue planets, in the simplest terms, are celestial bodies that behave much like the planets we're familiar with. They have mass, gravity, and often a spherical shape. But here's the catch: they don't orbit a star. Instead, they roam the vast expanses of the cosmos, all on their own. Now you might be wondering, how do they form? Well, it's a bit of a cosmic game of chance. Some rogue planets are born from the same swirling disks of gas and dust that create stars and their accompanying planets. Occasionally, these infant planets get a gravitational kick from other celestial bodies, catapulting them out of their nascent star systems and into the interstellar wilderness. Others might have started life as ordinary planets comfortably orbiting a star, but due to catastrophic events like a close encounter with another star or a violent collision, they're flung out of their home systems, becoming interstellar nomads. Characteristically, rogue planets are dark and hard to spot. This is because they lack the illuminating glow of a nearby star. But don't let their shadowy existence fool you. Some of these rogue planets are thought to be capable of supporting life under the right conditions. Yes, you heard right. Life might exist in the inky blackness of these celestial wanderers. Picture this: a rogue planet with a molten core could provide geothermal heat, creating a subsurface ocean of liquid water, a potential habitat for life. Equally, a rogue planet with a thick atmosphere could trap and distribute heat, making the surface habitable. But let's not get too carried away. The possibilities are thrilling, but we're still in the early stages of understanding these fascinating celestial bodies. In conclusion, rogue planets are not your everyday planets. They are the lone wolves of the cosmos, wandering the interstellar space untethered to any star. They are mysterious, elusive, and possibly even life-sustaining. What a marvel of the universe. But how do these rogue planets differ from the ones we're familiar with? Well, let's dive into the striking differences that set rogue planets apart from their regular counterparts. The first and foremost distinction lies in their orbit. Regular planets like Earth or Mars follow a well-defined path around their parent star, be it the Sun or any other star. They are bound by the gravity of the star, which holds them in their respective orbits. On the other hand, rogue planets are the mavericks of the cosmic world. They do not orbit any star and instead roam freely in the vast expanse of the galaxy. They have either been ejected from their original planetary system or formed on their own in interstellar space. Next, let's talk about climate. The climate on regular planets is heavily influenced by the energy they receive from their parent star. This energy is vital for driving weather systems and supporting life as we know it. For instance, life on Earth wouldn't be possible without the sun's warmth and light. In contrast, rogue planets are not bound to any star, and thus they do not receive a constant source of heat or light. This makes their climate extremely harsh and cold, often reaching temperatures far below anything we experience on Earth. The absence of a consistent energy source also implies that the chances for life as we understand it are slim on these wandering planets. Finally, the potential for supporting life varies greatly between these two types of planets. Regular planets, particularly those in the habitable zone of their star, could potentially harbor life. Our Earth is a prime example of this. However, for rogue planets, the odds are stacked against them. Their lack of a parent star and the extreme conditions prevalent make them unlikely candidates for life. Despite this, some scientists speculate that under the right conditions, life could potentially exist in subsurface oceans heated by the planet's core. In essence, While regular planets dance in the cosmic ballet around their stars, rogue planets are the solo performers in the universe's grand stage. How do we even know rogue planets exist if they're so elusive? A fair question indeed. Well, the discovery and study of rogue planets are fascinating exercises in cosmic detective work. Scientists use a range of methods to detect these elusive celestial bodies. The most effective of these is a phenomenon known as gravitational microlensing. This technique capitalizes on the fact that mass bends the path of light. So, when a rogue planet passes between Earth and a distant star, it bends the star's light around itself, creating a temporary magnification effect. The star appears brighter for a short while, a telltale sign that something like a rogue planet is passing by. But gravitational microlensing isn't the only tool in our interstellar toolbox. Other methods involve tracking unexplained movements of stars. You see, rogue planets, despite their solitude, still exert a gravitational pull, and although this pull is weak, it can cause nearby stars to wobble ever so slightly, a subtle dance that attentive astronomers can spot. Then there's the method of direct imaging. While incredibly challenging due to the absence of a star's illuminating glow, advancements in infrared technology have made it possible to detect the heat signature of rogue planets, revealing them against the cold backdrop of space. The study of rogue planets is a relatively new field, and we're still learning. But every discovery is a piece added to the cosmic jigsaw puzzle. Each rogue planet found teaches us more about planetary formation, survival, and the potential for life beyond the confines of a solar system. So, even though rogue planets are dark, distant, and elusive, they're not entirely invisible. Through the lens of highly sophisticated telescopes and the minds of dedicated astronomers, these solitary wanderers unveil their secrets. Even without a star's light to reveal them, these elusive wanderers can't completely hide from our inquisitive eyes. Each discovery is another testament to human curiosity and our unending quest to understand the universe in all its vastness and complexity. Why should we care about these rogue planets? What's their significance? You might ask. Well, these celestial nomads have a lot to teach us, and their potential significance is as vast as the universe itself. Let's start with planetary formation. Rogue planets are like the black sheep of the planetary family, formed under conditions we're still trying to understand. They challenge the conventional wisdom that planets must orbit stars, pushing us to rethink our theories. By studying rogue planets, we get to peek into the mysterious cradle of planetary birth, enriching our understanding, and possibly even rewriting the textbooks on planetary formation. But the intrigue doesn't stop there. Rogue planets also offer exciting possibilities when we think about the search for life beyond Earth. Traditionally, we've focused on planets within the so-called Goldilocks zone of stars. Not too hot, not too cold, but just right for liquid water to exist. But what if life could exist in more extreme environments, like on a rogue planet? Consider this. A rogue planet, despite its lack of a sun, could potentially harbor life beneath its surface. These planets may have internal heat sources like radioactive decay or tidal heating, which could create subsurface oceans, much like those suspected on Jupiter's moon Europa. These oceans could, theoretically, be home to life forms, making rogue planets intriguing targets in the search for extraterrestrial life. And there's more. Rogue planets could also serve as stepping stones for interstellar travel. They could provide resources or serve as waypoints in the vast distances between stars. Imagine a future where humanity hops from one rogue planet to another on our journey through the cosmos. So while rogue planets may be lonely drifters in the cosmos, their existence holds fascinating possibilities and questions for us to explore. While they may not fit into our traditional understanding of what a planet should be, their unique characteristics offer a wealth of opportunities for scientific discovery, and maybe, just maybe, a glimpse into the future of space exploration.